Somewhere over the Pacific right now, the atmosphere is doing something it does maybe a handful of times a year, and almost nobody outside of a weather office has noticed yet. The pattern that has controlled this country's weather for weeks is about to break. Not shift a little, not nudge a few degrees one way or the other, break. And when a pattern like this flips, it doesn't flip quietly. It flips like a switch being thrown. And everything downstream of that switch changes at once. The heat that's been parked over the middle of the country is about to get shoved out of the way. The storm track that's been running one direction is about to bend into a completely different shape. And places that have been dry for weeks are about to get hit with more rain in a few days than they've seen in the entire month before it. This is what meteorologists mean when they talk about a pattern shift. And I want to walk you through exactly what's driving it. Because once you see the mechanism behind it, the next week of forecasts is going to make a lot more sense than it does right now, just scrolling through a weather app. Here's the short version before we get into the details. High up in the atmosphere, 5 or 6 miles above your head, there's a river of fast-moving air that circles the entire planet. It's called the jet stream, and it is, more than almost anything else, the thing that decides what kind of weather you get. Right now, that river has been running in a pattern that's kept warm air locked over the central United States for an extended stretch. But rivers don't run in straight lines forever. This one is about to bend hard, and when it does, it's going to drag an entirely different air mass into places that have been baking while pushing the current heat somewhere else entirely. That's the setup. Now let's get into why it's happening, what it actually means day by day, and the one part of this transition that tends to catch people off guard even when they've heard the forecast. Because here's the thing, nobody tells you about a big pattern change. It's not the extremes on either side of it that cause the most trouble. It's the transition itself. The actual moment where one weather regime hands off to another is where the atmosphere gets unstable, and instability is where you get the kind of severe weather that catches people without an umbrella, without a plan, and without warning. I'll walk you through exactly where and when that transition window opens up. But first, you need to understand what's actually moving up there, because a pattern shift sounds abstract until you see the mechanism behind it. And once you do, it stops being abstract and starts being something you can actually plan around. If breakdowns like this are useful to you, the ones that explain the why instead of just handing you a 5-day forecast and calling it a day, go ahead and subscribe and turn notifications on. Pattern shifts like this one tend to keep evolving right up until the moment they arrive, and I want you to be the first to know if the timing moves. That's the whole point of this channel. Not hype, not panic, just a clear picture of what's actually happening in the atmosphere and what it means for you. All right, let's get into the mechanism, because this is where the whole story starts. Think of the jet stream like a river cutting through a landscape. Most of the time, that river doesn't run in a straight line. It bends and curves depending on what's in its way, the same way a real river bends around a hill or a rock formation. When the jet stream runs in a relatively flat, straight pattern, weather tends to stay put. Whatever's sitting under it stays sitting under it. That's exactly what's been happening with the heat parked over the central US. The river's been running flat, and the warm air underneath it has had nowhere to go. But rivers of air don't stay flat forever, because the atmosphere is always trying to balance out temperature differences between the poles and the equator. Right now, there's a strong temperature contrast building between the cooler air sitting up over Western Canada and the warm, moisture-rich air that's been dominating the middle of the country. When that contrast gets strong enough, it forces the jet stream to buckle. Instead of running flat, it starts to dip south in one place and bulge north in another, carving out what meteorologists call a trough and a ridge. And that dip, that trough, is exactly what's forming right now over the western half of North America. Here's why that matters so much. When the jet stream dips south like that, it doesn't just bring cooler air with it, it drags the entire storm track along for the ride. Think of the jet stream as the highway that storms travel on. If the highway used to run north of the country, keeping storms up in Canada, and that highway suddenly bends south through the middle of the US, every storm that would have missed you before is now aimed directly at you. That's the essence of a pattern shift. It's not that new weather appears out of nowhere. It's that the road system in the sky gets rerouted, and everything traveling on it gets rerouted along with it. So let's talk about what that actually looks like on the ground day by day, because this is where it stops being abstract atmospheric physics and starts being something you need to plan your week around. And I want to be upfront. Timing on a pattern transition like this can shift by a day or more as new data comes in, so treat this as the shape of what's coming, rather than a locked-in schedule. In the early stage of the transition, the heat that's been sitting over the Central Plains starts to feel the first signs of pressure from the west. You won't necessarily notice a dramatic temperature drop yet, but you'll start to see the sky doing things it hasn't done in weeks. Building cloud cover in the afternoons, a little more humidity in the air as moisture starts getting pulled north. Ahead of the approaching system, this is the atmosphere loading the chamber. The energy that's been building under that heat dome doesn't just evaporate when the pattern shifts, it has to go somewhere. And where it goes is into the storms that form right along the boundary between the old air mass and the new one. As the trough digs in deeper, that boundary, the line where the retreating warm air meets the advancing cooler air, becomes the most active stretch of real estate in the entire country. This is where you get the classic ingredients for severe weather stacking on top of each other. Warm, humid air at the surface, cooler, drier air pushing in aloft, and strong winds at different levels of the atmosphere blowing in different directions, which is exactly the kind of setup that lets storms start rotating instead of just producing rain. If a supercell forms along that boundary and the ingredients here genuinely support it, it can produce large hail, damaging wind, and in the more favorable corridors, tornadoes. This is usually the most volatile day of the entire transition because it's the day where both air masses are still fighting for position and neither one has won yet. Once the front actually pushes through, the character of the weather changes fast, sometimes within a matter of hours. Temperatures that were pushing well into the 90s or beyond can fall 20, 30, even 40 degrees behind a strong enough front, especially at night when that colder air mass settles in fully. This kind of temperature crash isn't just uncomfortable, it can catch people genuinely off guard, especially if they've spent the last week adapting to extreme heat and haven't been paying attention to the forecast. Farmers watch this transition closely for a reason. A sharp enough temperature drop at the wrong time of year can stress crops that have spent weeks acclimating to heat, and in some regions, an unusually early cold snap can bring frost risk that wasn't on anyone's radar a week earlier. Behind the front, once the cooler air fully settles in, the rain doesn't necessarily stop, it often just changes character. Instead of the explosive rotating storms that come with the frontal passage itself, you tend to get steadier, more persistent rain as the upper level trough continues to funnel disturbances through the same general corridor for days after the initial front passes. And this is where the quiet threat of this whole pattern shift lives, because after the dramatic storms get all the attention on the first day or two, the days of steady rain that follow can end up dropping more total water on saturated ground than the headline event did. Rivers and streams that were running low during the preceding dry stretch can rise fast, and low-lying areas that haven't seen significant rain in weeks can flood surprisingly quickly because the ground, baked hard by the preceding heat, doesn't absorb water the way it normally would. Hard, dry soil sheds rain almost like pavement does, at least for the first significant rainfall after a long dry stretch, which means flash flooding risk in the days right after a pattern shift is often higher than people expect given how dry things were just a week earlier. I want to slow down on that point because I think it's the single most underappreciated part of any major pattern transition. People hear that a heat wave is ending and rain is coming, and their instinct is relief. Finally, some relief from the heat. And that instinct isn't wrong exactly, but it can make people let their guard down at precisely the moment they shouldn't. The most dangerous window in a pattern shift isn't the peak of the heat, and it isn't necessarily the peak of the cold that follows it. It's the handoff in between, the day or two where the atmosphere is genuinely unstable, throwing severe storms one direction and flash flooding potential the other, all while everyone's mental model of the weather is still stuck on last week's heat wave. Now, I want to be honest about where the confidence levels sit here because I think that matters more than sounding certain about every detail. The broad shape of this pattern shift, a trough digging into the western half of the country and pushing a more active storm track through the middle of the US, that part I have real confidence in. The models have been remarkably consistent on that overall structure for several days running, and that kind of agreement across multiple independent forecast models is usually a good sign that the broad pattern is locked in, even if the fine details aren't. What I'm less certain about is the exact day the most severe weather materializes and exactly which specific stretch of the boundary sees the worst of it. Those details can still shift by a day or more as we get closer, especially with a pattern this active. So treat the day-by-day breakdown as the general shape of the threat rather than a locked-in schedule for any specific city. Let's walk through what this actually looks like for someone living through it, because a pattern shift sounds like a weather map until you put a person inside it. Picture someone living in a town roughly in the middle of the country, somewhere that spent the better part of 2 weeks under genuinely oppressive heat. The lawn is starting to brown. The air conditioner has been running nonstop, and then one afternoon, the sky looks different. Not dramatic yet, just different, taller clouds building earlier than they have all week, a little more humidity in the air than the dry heat they've gotten used to. That's the boundary approaching, even if nobody's called it that on the local news yet. The next day, the forecast starts using words it hasn't used in weeks. Severe thunderstorm watch, possible large hail, and for some corridors, a tornado watch. This is the volatile day, the one where both air masses are still contesting the same ground. Storms fire in the afternoon heat, feeding on all that built up energy from the preceding heat wave, and by evening, some of them have organized into something more dangerous than an ordinary summer storm. This is the day where the difference between a bad storm and a genuinely dangerous one comes down to whether people are paying attention to warnings in real time, not just glancing at a 5-day forecast from the morning. By the following day, the front has pushed through and the temperature difference is almost hard to believe if you were outside the day before. What was a high near 100 degrees is now struggling to reach the 70s. People who spent the last 2 weeks in shorts and sandals are suddenly digging out a light jacket. And the rain that follows doesn't come as one dramatic burst. It settles in, day after day, steady rather than explosive. By the third or fourth day of that steadier rain, streams that were nearly dry the week before are running high, and a low spot on a rural road that's never flooded, in living memory suddenly has standing water across it. Nobody in that town would have predicted flooding 2 weeks into a heat wave. But that's exactly the trap a pattern shift like this can set, because the danger doesn't announce itself with the same drama the heat did. So here's what all of this actually means for you, depending on where you sit relative to that shifting boundary. If you're currently under the heat that's about to get displaced, don't let the good news of cooler weather coming make you complacent about the days right before it arrives. The energy that's been building under that heat dome for days or weeks doesn't just quietly dissipate. It often gets released in exactly the kind of severe storms that form along a strong frontal boundary. Keep your phone's emergency alerts on through the transition, not just during the heat itself. Know where you'd shelter if a tornado warning came through, and don't assume that because the heat is ending, the most dangerous day of the pattern is already behind you. Often it's the day of the actual frontal passage that carries the highest severe weather risk of the entire stretch. If you're in the path of the incoming trough and the active storm track behind it, prepare for a genuine whiplash in conditions. Have layers ready for a temperature swing that can be dramatic enough to catch you off guard if you've spent the last couple weeks dressing for heat. If you're a gardener or work in agriculture, pay attention to any frost risk that shows up in the days following the front, particularly overnight, since a sharp cold snap arriving while plants are still acclimated to warm weather can do real damage even without a hard freeze. And if you're anywhere that's had a dry stretch recently and is now looking at multiple days of rain behind this front, take the flash flood risk seriously, even though it doesn't feel intuitive after weeks of dry weather. Ground that's been baked hard doesn't absorb water well in the first significant rain after a dry spell, which means flooding can happen faster and in places that don't normally flood. If you ever find yourself looking at a flooded road and wondering whether it's shallow enough to drive through, the answer is always no. Turn around and find another way. It is never worth the risk, no matter how many times you've driven that same stretch of road under normal conditions. None of this requires panic, and I want to be clear about that, because a pattern shift like this is honestly a completely normal part of how weather works in this part of the world. It happens multiple times a year, and most of the time it passes through without anyone getting hurt. What it does require is paying attention during the transition window specifically, rather than assuming that because the extreme heat is ending, the riskiest part of the pattern is over. In a shift like this, the most volatile weather usually happens right at the handoff, not on either side of it. Step back and look at the whole thing one more time, because I think it's genuinely one of the more elegant stories in weather when you actually understand the mechanism behind it. This isn't random. It's not a heat wave that just happens to end and a storm system that just happens to follow. It's one connected process, a river of air 5 miles above your head, bending because of a temperature contrast building on a continental scale, dragging an entirely new storm track along with it, and handing off the country's weather from one regime to another in the span of just a few days. Understanding that mechanism is what turns a confusing string of forecast alerts into something you can actually see coming and plan around, instead of just reacting to whatever alert shows up on your phone that day. I'll be tracking this pattern as it continues to develop, especially the exact timing of that frontal passage and which corridor ends up seeing the most severe weather when the two air masses finally collide. If you want to catch that update the moment the picture sharpens, subscribe and turn notifications on, because that's genuinely the only way to get it in time for it to matter. And before you go, I want to hear from you. Have you ever lived through a pattern flip like this? A sudden swing from extreme heat straight into severe storms and a temperature crash? What was it like where you were? Drop it in the comments. I read everyone, and it's always interesting to hear how differently this kind of transition plays out depending on where people actually live. Stay safe out there. I'll see you in the next one.